All right, guys. Landan Quartemont here. I wanted to shoot you guys a quick recap of the most recent GDE office hours. We actually kicked it off this week. This is an event that I'm doing every Wednesday at 11 a.m. Central Standard Time. So real quick on what is GDE. It stands for Google Developer Expert. It is a program that Google has employed on a number of different fronts within the workspace and just general development ecosystem within Google. So they are essentially incentivizing developers to be on a volunteer basis, assisting the community and helping out in whatever way they can. So depending on your area of expertise, this could look, so many different ways. But for us, and my focus is going to be AppSheet in specific. I'm trying to engage more with the AppSheet community forums, as well as start these different programs that are going to help cultivate a greater knowledge of the tool for those in the community and so on. So this is one effort at that, and it's an easy time for people to come get questions answered, be able to share screen and walk through problems that they may be facing and try to get those solved. So I've worked with the tool for over 5 years, done tons of hours in consulting and development, and am very eager to help you guys out in whatever way I can. But again, just wanted to plug what I'm doing here. Again, this is going to happen 11 o'clock a.m. Central Standard Time on Wednesday mornings. All right, so let's get into it. Today we are going to be talking about scaling AppSheet apps. And I wanted to give a quick overview of what we went over in this past meeting. So we hit it at a very high level, and we dove in some areas, but really I'm sure a whole session could be merited for each and every concept here that I'm going to cover. But at a high level, we'll kind of break into two macro categories. So the first is going to be data and backend. The second is going to be within the actual AppSheet app itself and the various components therein. So within the realm of data backend, we're going to hit data source limitations. We'll talk about data structures that are specific for how to optimize that performance. We'll talk about backend performance resources. And then within the in-app components, we will talk about security filters. We'll talk about optimizing virtual column usage. We'll talk about slices and how to optimize performance there. And then finally, we'll talk about app settings that you can change to increase app performance. Okay, moving forward, we'll jump into the backend first. So let's talk a little bit about data source limitations. So I loosely define this as API rates or row count limitations that you may experience depending on your data source backend. So among the data source backends, you really have two kind of macro categories. You have cloud-based spreadsheets, and then you have cloud SQL databases or data warehouses, things like BigQuery, Redshift, and so on. So there is a significant performance difference between those two macro categories, and you kind of work with different limitations within each of them. But to summarize, I would say, each data source is going to have its own limitations. So even within a macro category, if you're specifically isolating cloud-based spreadsheets, you're going to have different limitations going from Smartsheet to Google Sheets or Excel Online to Google Sheets. And I think that AppSheet is always trying to improve the way that it connects with these platforms. And so these limitations could change over time, as well as the platforms themselves are trying to improve. So they may improve the amount of API calls that can be made to that spreadsheet in a given minute, or, whatever the time frame is. But at a high level, you're looking at, depending on the data source, a certain data source may only be able to receive, 500 API calls a minute or something like that. I don't know the exact numbers, but I know that generally speaking, cloud-based spreadsheets are going to allow less concurrent usage relative to cloud SQL databases or data warehouses. In addition, the read and write time for Cloud SQL databases is going to be much faster than, uh, and by much faster, I mean in the ballpark of 30 to 40% faster than its counterpart, which would be the cloud based spreadsheet. So, with that being said, I'll move into talking about how to optimize data structures. And whenever I hit this concept, I am really talking about like what can you do as a developer to change the way that AppSheet may be reading your data in order to improve sync time and to reduce the amount of data that it has to read at one time, or basically giving it the easiest form of that data to read. And so we'll hit a couple different categories here, but at a high level, this is, trying to normalize your data sets and include critical fields so that we can employ security filters that will then reduce the amount of data coming into an AppSheet app at one time. And I didn't touch on this in the meeting, and I didn't have it in my notes here, but I would say a kind of an optimal sync time for any AppSheet application, if you can get it sub 7 seconds of sync time, you're in pretty good shape as an AppSheet app. So we want to do everything in our capacity to try to hit that target mark. That may not be applicable in all use cases, but it's a good target. I would say most use cases we can definitely hit that mark, averaging sync times below 7 seconds. Okay, so going back to data structures, a couple of best practices for us. So in general, we prefer smaller tables that are related to one another over larger flat tables that incorporate kind of more macro categories in one table. So oftentimes it's more beneficial to have a table like that broken out into parent and child relationships where you can. Again, this is not applicable to all use cases, as best practices are not the end all be all for every single case. Um, Secondly, remove redundant and unused columns. So especially in the evolution of an application, you'll identify attributes that are more or less relevant over time. And we just want to keep these tables as trim as possible. Column count in uh, in most use cases is not as relevant as row count, but it still does have performance impact. So if you have a table that has 50 columns and 20 of them are redundant or unnecessary now, do what you can to remove those. Obviously, that may create some downtime for users, and you want to plan around that and communicate maintenance windows and such. But that is a general concept that's going to help you out. Third item on my list is reducing and removing spreadsheet formulas. I think a lot of us already know this. We have run into errors in the AppSheet interface because we may have had spreadsheet formulas or so on. But one thing that is notable to communicate here, if you're using a cloud-based spreadsheet and you've got formulas that are running, sometimes AppSheet can't query the table data until your spreadsheet formulas finish calculating. And so you're adding unnecessary sync time on the front end of AppSheet grabbing data, because AppSheet is waiting for the spreadsheet to finish computations, which is unfortunate. So if at all possible, we like to move those to AppSheet as either virtual column or a static column with an app formula. Lastly, I would say implementing user and user variable tables. So we covered this in our meeting, and I do have an example. For sake of time, I'm not sure if I'll go there, but generally, I would highly, highly, highly recommend having for every single app a user table so that you can establish user specific parameters. Even, for example, a role that a user has. So maybe a role, maybe a standard user, maybe a user could be an admin, maybe a super admin. there are so many different ways to hierarchically categorize users, but oftentimes these will impact the data that is relevant to a given user. And we want to be able to identify that and make a match to the current user, and then be able to filter our data accordingly. So in our meeting, we talked about the difference between a user table and a user variable table. In most cases, I recommend having both. Reason being, there, depending on how many users you have in your app, you can definitely run into a scenario in which an admin or super admin is trying to actually modify a user's data. And if you are adding user variables inside your user table, you have that user who's trying to modify a variable within their own user record, and the admin trying to adjust, user data in their record at the same time. Somebody's data is going to get overwritten. And especially if the admin tries to apply their changes first, a couple of seconds before the other, what have you, then their changes are going to get overwritten whenever that user tries to modify their variable. So that can be quite problematic in certain circumstances. And for that reason, I highly recommend having a separate user variable table if you're trying to supply, custom user logic within your application. Moving to backend performance resources. This is especially relevant for Cloud SQL databases. But I think at a high level, I would like to cover with you guys the general progression of how AppSheet reads and filters data. Excuse me. So generally speaking, the progression is going to be, you have data in your database. That data is then queried by AppSheet servers. It is loaded. All of that data is loaded onto AppSheet servers, and then it applies security filters. So if you had 50,000 records in your database, or your biggest database table, all of that data goes into your AppSheet servers. Even if you're filtering it down to 500 records through security filters, it still has to pull the whole data set from that table. And then it moves it to the client device, at which time it then applies slice filters. Now, if you have a Cloud SQL database and you have, I would say, less complex filters as security filters, what will actually end up happening is AppSheet has a feature called active database filtering. And instead of pulling the whole table data from the database to AppSheet servers, it actually sends in a query that it uses to pull data to its servers. So instead of pulling that 50,000, it's actually only going to pull the 500 records into AppSheet servers, and it kind of bypasses that whole step for these security filters. So, and then the progression is normal from AppSheet servers. It goes to the client device, and then slice filters. Now, if you haven't worked a ton with databases before, I highly recommend, especially in your larger tables, employing a database index or indexes on your critical columns. So if you're, filtering by user, or you're filtering by a date in your security filter, you want to make sure that you have a corresponding index on those columns. That will improve the query performance and help AppSheet get your data to you faster. All right, so moving into the in-app components, first thing that we're going to talk about is a concept that we've already alluded to on a number of occasions, and that is security filters. So security filters are row-level filters that are applied to tables that you connect to your AppSheet app. Again, we already kind of covered the standard progression, but I can't emphasize that enough. That is a crucial concept to know conceptually of why are security filters relevant? Why are they different than slice filters? Again, in a normal setting, all of your table data is loaded into AppSheet servers, and then it applies filters there, and then it sends it to the client device. again, you get that extra added bonus if you are using a Cloud SQL database with less complex filters, where it actually sends in query parameters in its call to retrieve your data from your database, and doesn't actually have to apply those same filters at the AppSheet server level. So you gain a lot of advantage there if you're using a Cloud SQL database, and and for a lot of enterprise use cases and applications, that's the only way to get by, because the minimum table size is going to be in the ballpark of hundreds of thousands, if not even larger than that, in terms of row count. So yeah, I can't emphasize that enough. I think that's a really really important concept to understand. Um, Main recommendation I would have when considering security filters is, again, establish a user and or a user variable table to work in conjunction with your security filters, because it's going to be a huge benefit to you and give you the ability to customize logic and optimize your sync times for specific users and how they may be interacting with an application. So I'll give you one use case that I've worked with. We had a client that had a large fair of business. They worked in the asset tracking and management space, and they had a number of clients. I just say they had in the ballpark of 50 clients. Their biggest clients had over 50,000 assets that they were tracking with them, and their uh, the use cases within that were they had a number of services that they performed on each of those assets. So you can do the math yourself. You can already envision that asset table is really really large. It's over 100,000 records. The Sorry, over a couple 100,000 records rather. And then the services tables are massive as well, right? You've got in the ballpark of 500 plus thousand, a million records, and so on. And so right then and there, we're already thinking, okay, we needed to use a Cloud SQL database. And what we ended up doing is having a user variable table where we created a database view that was a trimmed list of assets per client. So they would first select a client. That was a variable. We use that to employ or to inform a security filter that then only brought in, in the ballpark of 50,000 assets, right? And then they had a trimmed list of assets. They select an asset, and then we only pull in the services and the whole of the asset data related to that one asset. So doing that allowed us to get our sync time down to in the ballpark of 6 or 7 seconds, which was a huge benefit relative to what they had beforehand. So bring that full circle, we used a bunch of different concepts in that use case. We changed the data structure, and we utilized a user or a user variable table to optimize those security filters. So really fun use case and a very exciting implementation of a number of concepts that we've talked about so far. All right, moving into virtual column usage. I think a lot of us are aware of how taxing virtual columns can be. I think that it's really helpful to know why they're taxing, and I would say this. So AppSheet is trying to calculate these a lot, and oftentimes we don't need the refresh rate that AppSheet is generally attempting to refresh these virtual columns at. So every time you sync the app, AppSheet tries to calculate or recalculate all of your virtual columns. In addition, every time you make a data change to the app, it recalculates those virtual columns. So problem with that is, again, for most rows, that is not necessary. And more times than not, you can isolate a specific row that you want to update at a given time. And I will give you a quick workaround for that. So in general, the types of virtual columns that are most problematic are going to be those that are using queries. So a select or a filter, just doing a general open table query. So we want to reduce those as much as possible, um, or we want to, instead of querying a whole table, we would like to rather query a related list. So if you're in a parent table and you need to query your child data, don't query the whole table. Query your related list column within that table, and that's going to be a much more performant way of doing that. Secondly, if we can, we would really like to move a lot of those queries to static columns. What we will do is we will trigger the update of that static column based on a condition that we apply. So if I am working in an inventory use case, oftentimes we'll see this with the way that it's structured is you may have a product, and that product has multiple inventory transactions, but what you want to know at a high level is, what is my current inventory of this product? Well, in order to do that, we have to do a sum aggregate on the transactions that have taken place related to that product. And so what we can do is actually have the current inventory be a static column in the product table rather than a virtual column. And then whenever we make a transaction, we can use an in-app action to update the corresponding product related to that transaction. And in doing so, it will recalculate that static column through the app formula, and we get our current inventory. So, yeah, that's at a high level. I think that's a huge benefit in the long run if you can try to move a lot of your virtual columns to be those static columns instead. Again, it's not possible in every use case, but in those where it is, it will definitely help your sync time. All right, wanted to talk a bit about slice performance. So slice performance is very similar to virtual column performance. Um, Again, AppSheet recalculates these computations every time you sync your app and every time you make a data change in the app. So again, this can be really intensive on AppSheet's computational engine, and it not only can affect sync time, but it can also affect app latency. So latency is whenever you click a button and you have to wait 3 seconds before your screen changes. That could be an indicator that you have a slice that is trying to perform a lot of computations, and you want to do what you can to optimize that. So how do you optimize? Well, in some cases, you can forego the slice altogether by using a link to filtered view. In many cases, we're creating slices because we want to constrain what rows enter a multi-row view. Well, instead, you may consider using a link to filter view, and that may solve your problem. If that doesn't work, you're going to want to optimize your queries. That means reducing the amount of times that you're making cross-table queries within a slice. So and that may not always be achievable. And when it's not, I would definitely recommend trying to think intelligently about your use case and see, is there any way that I could almost tell AppSheet, you don't need to worry about making this computation right now, or I will tell you when you can make this computation. And so you may have a variable in your user variable table that you use to indicate to AppSheet, okay, now I want you to calculate this slice. So in my last bullet point here, I said, preface your complex queries with a simple query. So, in this example, I said, if the value of the dashboard column related to the current user is not true, then omit all records. Otherwise, do this complex query, right? And so you kind of get to indicate to AppSheet when you want it to be calculating. And so it's not going to be slowing down your app on the for the majority of the user session. All right. Last item on the agenda here, we want to talk about app performance settings. So This is knowing which app performance settings you can modify to optimize your use case. And again, you can read through the definitions that AppSheet has in this menu. Again, if you want to navigate there, you can follow this picture. It's going to be in the settings drop down, and then you'll hit the views drop down. In performance, you'll be able to see a number of these. There are 6 in total, I believe. But I think the biggest hitters for app performance are going to be really server caching, quick sync, and delayed sync. So server caching is going to be where AppSheet stores data on its servers um, instead of having to retrieve like the whole data set every time you resync your app, especially for read only data. So if you have larger lookup tables, this is going to be a big benefit to you. It could improve your sync time by 20 or 30% if you turn it on. Because AppSheet is not having to query that table every time. It's actually maybe doing intermittent queries to bring data to AppSheet servers, and then it's just having to pull data in from the AppSheet server rather than your database every time for those larger lookup tables. Um, Moving to QuickSync. QuickSync is actually a really, really cool feature. I don't know that a ton of people have even explored it within the community. It's relatively recent, but it actually generally AppSheet is more so built for an offline environment, which means that you and I can be working on an app at the same time. And if you make changes, I don't necessarily see your changes unless I sync my application. Or it could, if you have on automatic updates, within the ballpark of 30 minutes, I may get your change if I am not actively making changes in my app. So that can be a bummer for a lot of use cases. Think about like a dispatch use case where, you know, a technician needs to be aware of when a dispatcher, assigns them to a job or changes data within a job or something like that. You want to be updated in real time on what's happening. And so QuickSync actually allows us to do that. Now, there is a lot of nuance to it. Certain use cases don't apply. So, at least on their definition, they say, hey, if your app uses external formulas or virtual columns that need to be updated with each data change, then this may not be the uh, best parameter to turn on within your application. But if you don't have those things, it would be a huge benefit. And the uh, the sync time of your app will be more or less seamless, and changes that other users make will be visualized in your instance of that app in close to real time. Finally, last thing I would like to talk about is the delayed sync. And if you don't have it on, I would definitely recommend it. What it means is that whenever users make changes in their app, data changes, that is, it is not automatically trying to sync your app. It's stopping the user experience. So it will start to accrue changes in the top right of your screen. And those changes are just going to slowly fade into the app experience, but it's not going to interrupt the user experience in order to do that. Okay, so that is a wrap for us. I know that was a lot of content. Um, if you benefited from this, please consider, giving this a thumbs up, a like, subscribe to our channel, or come to the next office hours. Again, I will be posting a link in the description that will allow you to find the sign up sheet for that. Again, 11 o'clock, Wednesdays, Central Time. Hope to see you there.